Chapter 1, Video 3. Today we're going to discuss the heart chambers. We're going to continue with the anatomy of the heart. We went over in the previous lecture the way the blood travels through the heart. So now you can start learning what each structure does and what the purpose is of it. First, we're going to talk about the right atrium. The big thing that you need to know about the right atrium is it receives deoxygenated blood from the body. The superior and inferior vena cava brings in the deoxygenated blood, and the first place that it goes is into the right atrium. So this is blood coming from that vena cava, and it is deoxygenated. In the right atrium, the O2 saturations is 60% to 75%. So that's important. That's low. It's so little oxygen that blood appears to be maroon in color, which is a deep brownish red. Once the blood leaves the right atrium, it goes down to the right ventricle. So the right atrium is one of our heart chambers, and then we have the right ventricle. The right ventricle is the oxygen saturations in the right ventricle is 60 to 75%. It's the same. And the CO2 concentration, the waste level is really high. Again, this blood is deoxygenated. It's been out at the body. It came in through the superior inferior vena cava, went to the right atrium. Now it's at the right ventricle, and it's still deoxygenated. As it leaves that right ventricle, it goes into the lungs, and then it comes back to the left atrium. So now we're going to talk about the left atrium. The left atrium receives oxygenated blood from the lungs, okay? So the blood has been through the lungs. It's blown off all of the waste. It's blown off the CO2, and now it has oxygen. So it's picked up oxygen, and it's blown off that waste, that CO2. So we have a really high oxygen saturation here. The oxygen saturation in the left atrium is at 100%. It is bright red in color, and the CO2 concentration here is extremely low because it's removed by the lungs. And again, the left atrium delivers blood down to the left ventricle. The left ventricle is the last heart chamber that we're going to talk about. The CO2 concentration here, it's minimal. We still have a high oxygen saturation, and this blood appears to be very bright red in color. The O2 sats in the left ventricle is at like 100%, okay? So now you know what each of the four heart chambers are. We have the right atrium, the left atrium, the right ventricle, and the left ventricle. I'm going to show you a slide of a heart that's kind of dissected so you can see the inside. This is the right atrium. This is the left atrium. This is the right ventricle, and this is the left ventricle. So the ventricles sit here on the lower half of the body of the heart, and then the atriums sit on top. They're the top chambers of the heart. So these are like small chambers: right atrium, right ventricle, left atrium here. So that kind of gives you an idea of what you're looking at there. So when we talk about the heart chamber, we need to know the difference between the two atria and the two ventricles. The atria's purpose is to deliver blood to the ventricles beneath them. It's a thin wall, low pressure chamber, okay? So when we're talking about the atrium, we look here, you can see the wall here in this dissected picture is thinner. If you look down at the ventricles, we see we got more muscle here, and that'll make sense to you in just a second. The ventricles, these are high pressure chambers. The left ventricle generates the highest pressure. The left ventricle is 3 times the muscle bulk of the right ventricle. The ventricles must contract harder and stronger to deliver blood to the body and to the pulmonary system, okay? So if you think about it, when the blood goes into the right atrium and the left atrium, it's got gravity. The blood's flowing down to the ventricles. So gravity is on its side. So it doesn't have to pump as hard to get blood down to those ventricles. But as the blood goes into those ventricles and it's moving forward, the right ventricle has to push it up to the lungs and the left ventricle has to push it up and out to the body. So it's meeting more resistance. So that's why it's a higher pressure chamber in the septum. The muscle thickness is thicker. So looking here, I want to talk to you guys about the septum. When we talk about the septum of the heart, it divides the heart into right and left. So this is the right side of the heart, and this is the left side of the heart. And this component right here, this is the interventricular septum. The septum divides it into right and left. So this is the septum, and it's also known as the interventricular septum. We have an interatrial septum as well that separates the atria. So the septum separates the heart into right and left, but the interatrial septum separates the atria from right and left, and the interventricular septum separates the ventricles into right and left. Now, moving forward, we've talked about the heart chambers. Let's continue to talk about the heart structures. The heart has valves, okay? We have 4 different valves. The purpose of a valve is to prevent the backflow of blood. So anywhere in the body that there is a valve, whether it be in the heart, whether it be in the legs, the valve's purpose is to keep that blood propelling forward and not moving backwards. So we have 4 different heart valves here. We have the pulmonic valve, we have the aortic valve, we have the tricuspid valve, and we have the mitral valve. So first we're going to talk about the 2 semilunar valves. The 2 semilunar valves are the pulmonic valve and the aortic valve, and these are listed in the blood flow of the heart. So we know that pulmonic valve lies between the right ventricle and the lungs, and we know the aortic valve lies between the left ventricle and the body. These are semilunar in shape, okay? So just know that they prevent that backflow of blood. And looking at this picture here, when we look at this, you can see, I want to show you guys, this is the aortic valve. It sits right here. And then when we look at the pulmonic valve, I don't know if you can really see it on this slide. Right here it is, the pulmonic valve. So, our pulmonary valve, this is the semilunar valve, and then we have our aortic valve, which is a semilunar valve. This is the 2 structures right here. So, the pulmonic valve sits between the right ventricle and the lung, and then the aortic valve between the left ventricle and the body. So, that gives you an idea of what those 2 look like. They appear half moon in shape. Now, moving forward, we're going to talk about our atrioventricular valves. These are called atrioventricular valves because they lie between the atrium and the ventricles, okay? We have a tricuspid valve and we have a mitral valve. The atrioventricular valves are also known as the AV valves. Again, they're located between the atria and the ventricles. And these valves, they're supported by what they call chordae tendineae. They're like tendon cords. They're attached to the papillary muscle. And they're muscles that outpouch from the ventricular wall. And they anchor the valve and they keep these chordae tendineae kind of anchor the valve and they keep them from flopping back and forth. So looking back, let's go over here. And I want to show you this picture. I'm going to refer back to this picture. This is the tricuspid valve. It is, and you can see here that this is the chordae tendineae that keep that valve from flipping back. And then on the left side, this is the mitral valve. Again, these are AV valves or atrioventricular. You may hear them termed AV valves, or you may hear them termed atrioventricular valves, because they lie between the atrium and the ventricle. The mitral valve is also known as the bicuspid valve. So that term is used interchangeably, okay? So if you hear bicuspid valve, that's the same thing as the mitral valve. If you hear mitral valve, that's the same thing as the bicuspid valve. One thing that we need to know about heart valves is they open and close based on the changes in pressure, and they only open in the direction of the blood flow. The valve's closure is responsible for the sounds made by the beating heart. So that lub-dub sound that's made by, that lub-dub sound that you hear when you put the stethoscope on the heart, that lub-dub sound is made by the closing of these valves. So listen to me and take this into consideration and write this down. The S1 sound, you have an S1 and an S2 sound. The S1 sound, that's that first sound that you hear. That is the closure of the mitral and tricuspid valve. That S2 sound, that dub sound, you got the lub-dub, lub-dub. That S1 is the closure of the mitral and the tricuspid. That's the first sound that you hear. Then the S2 is the second sound, and that's the closure of the aortic and pulmonic valves. The pulmonic valves open upwardly only when the pressure in the ventricle is higher in ventricles than awaiting in the pulmonary artery. So the blood flows upward. So we have to have a higher pressure gradient in that area of that ventricle and a less gradient on the other side, and then this will open. It kind of pushes those open. It will open and allow the blood to move freely through and not in a backward direction. And then we want to discuss our great vessels. Remember, we said the great vessels emerge from the base of the heart. The great vessels include the superior vena cava. That's the vein that returns the deoxygenated blood to the right atrium from the upper body, like from the head, the neck, the upper chest, and the arms. And then we have our inferior vena cava. This is the vein that returns the deoxygenated blood to the right atrium from the lower body, lower chest, abdomen, and legs. So we have a superior and inferior vena cava. These are both veins. They both bring in deoxygenated blood, but the superior brings it from the upper body and the inferior brings it from the lower body. The pulmonary artery, we have a pulmonary artery and we have a pulmonary vein and we have an aorta. The pulmonary artery is the large artery that takes the deoxygenated blood from the right ventricle to the lungs. And then we have the pulmonary veins, and that's the 4 veins that return oxygenated blood from the lungs to the left atrium. These are large veins. And then the aorta is the largest artery in the body. It feeds the organs of the body. And if y'all will, please look at table 1.2 and 1.3. Another thing that I want to mention to you, arteries generally carry oxygenated blood, and veins carry deoxygenated blood. One thing that I want to point out to you, the pulmonary artery is the only artery in the body that carries deoxygenated blood. So when we're looking at that picture of the blood flow through the heart, steps 1 through 6, that blood is deoxygenated. And then it has to go through that pulmonary artery to get to the lungs. So the left side, steps 1 through 6, when I had you label it, that's deoxygenated blood. It goes through that pulmonary artery to get to the lungs. Veins tend to carry deoxygenated blood. But the pulmonary veins are the only veins in the body that carries oxygenated blood. When the blood leaves the lungs, it's picked up the oxygen and it travels through those veins back to that left atrium. So please take a peek at that. If you have any questions, please let me know. Thank you.